Hello, this is Team NoRAGrets, and this is our submission for the 2024 Databricks Hackathon, the Privacy Act chatbot. The use case we are attempting to solve is the retrieval of relevant information from consumer data privacy laws. For some background, there has been an increasing prevalence of data breaches and consumer concerns that has led to a worldwide focus on data privacy. In 2018, the European Union passed the General Data Protection Regulation, but so far the US has not yet passed the American Data Privacy and Protection Act, which would be a similar national law. However, 13 states have passed individual state privacy acts, with many more to follow. While all acts contain similar provisions, the differences between states pose challenges for companies doing business in multiple states. So the aim of our Privacy Act chatbot, which is powered by Retrieval Augmented Generation, or RAG, is to accept user queries on a state's data privacy laws, to search the data privacy regulation from the given state, and to retrieve and present the most relevant response. The text of the legislation of each state that has passed the Data Privacy Act can be publicly found on the internet in PDF form. These PDF files are stored in Databricks volumes, and then they are read and cleaned using Python. Next, a Llama tokenizer generates appropriately sized text chunks. These chunks, along with the user's query, are transformed into embeddings and written to delta tables. For this chatbot, we decided to use embedding models by both OpenAI's Ada 2 and BAAI's BGE model. Next, vector search indexes were built from the delta tables for each embedding model. From these indexes, Databricks vector search endpoints and clients were created. We used the new Mixtral 8x7b similarity search to return the top 10 results. These results were then fed into a re-ranker, which recomputed relevant scores. Finally, the output of the top result was fine-tuned and summarized using the Mixtral 8x7b instruct model. There are a number of aspects of our solution that make it relevant and unique for today's data landscape. Firstly, the emergence of data privacy concerns makes this a useful tool for both consumers and companies. For consumers, the chatbot can help them understand their privacy rights. And for companies, the chatbot can help them understand their responsibilities for data privacy and the penalties if they fail to do so. Additionally, by ingesting the privacy acts of all states, our multi-state approach allows state-level filtering of the documents, and the corpus of the vector search index is easily scalable to accommodate additional documents from states when they pass their data privacy legislation. One particularly unique aspect of the solution is using retrieval augmented generation from legal documents. We use the extended capabilities of RAG to handle the length and complexity of legal documents. Because legal documents are rarely queryable via search engine, our chatbot can allow human users to save a significant amount of time from having to manually search the text. Finally, we incorporated a multi-large language model framework in our solution in order to maximize the effectiveness of each model. The combination of embedding models, in particular, provides a diverse array of results available for re-ranking, and we took advantage of the seamless integration between Databricks and both open and closed source models.
Let's take a closer look at the Privacy Act documents. We retrieved documents from each state's website. For example, this is the website for the Colorado Privacy Act. The legal documents are available in PDF format. We stored these PDFs in a Databricks volume for our chatbot to reference. We then used a Databricks notebook to begin processing the PDF text. The notebook cleans the text from the PDF documents, making it easier to create and manage meaningful embeddings later on. To improve our RAG accuracy, we created embeddings using the BGE large embedding model and OpenAI's Ada embedding model. The large language models have limited context windows. To make sure the PDF text fits within the context window, we split up the documents into smaller chunks. We create the embeddings and store them in a table. We can now review the chunks and embeddings created by each model alongside the original PDF content and other metadata. Here, we create vector search clients to use these embeddings when performing RAG document searches. Since the embeddings are managed separately for each of the embedding models, vector search clients have been created for both the BGE and ADA embeddings. We create endpoints and indexes for each of the vector search clients. These help our chatbot to perform the RAG document search. Here, a filter is used to limit the document search to only documents that a user asks about. Search functions are created for both the ADA and BGE models. To give our search the best chance of success, we combine the results of the ADA embedding search and the BGE embedding search. The results are then processed by a re-ranker. In this example, we use a BGE re-ranker large model to determine which result is the best answer to the user's question. Finally, we use the Databricks Mixtral 8x7b instruct model to summarize the top-ranking document and return the result to the user. In another Databricks notebook, we use LangChain to efficiently chain together the user prompts and perform the RAG search. We also added some guardrails to prevent the model from returning responses that are out of scope for the RAG application. In this example, the user asks an out-of-scope question: "What is your favorite song?" The model has returned the correct response. In this example, the user asks, "How would a California resident request their private data from a company?" The model has returned a correct document. In this example, the user asks, "What are consumers' rights in the Oregon Privacy Act?" We can see that the document search has returned a good match. The user asks a question about biometric data in the Colorado Privacy Act. Once again, we can see that the chain is returning highly accurate results